Hello guys, welcome to my channel. I hope you all are fine. In this video I am going to show the process of solving root locus step by step. And if you are new in my channel, then please subscribe to my channel for regular updates and don't forget to press the bell icon. This is the root locus. So these are the construction points. So how to construct the root locus? So first point is, see, the root locus is symmetrical about x-axis. It is the mirror image of the upper x-axis graph. Okay, so the root locus will be like this. It is a mirror image, so this is a mirror image. Okay, this and this two will be the mirror image. Next is, second point is, let P is equals to number of the open loop poles and Z is equals to number of the open loop zeros. Then the number of branches terminating at 0 is Z. Okay, and the number of branches terminating at infinity is P minus of Z. Okay, and the third point is a point on this is called the asymptotes. This P minus of Z is called asymptotes. Okay, our third point is a point on real axis is said to be on the root locus if to the right side of the sum of the open loop poles and zeros is odd. Okay, so what this statement means? See, this is a S-plane. This is one pole. This is one pole, and this is one pole. Okay, this is one pole. See, this is in S is equals to 0. This is in S is equals to 2, and this will be in S is equals to 4. So we have to start checking from this point. Okay, see, in this point there is no such pole and 0. Okay, we have to check from this side. We have to start checking from this side, and we have to see in the right side. So see, in this is the point, there is no such points in the right side, means 0. So 0 is an even number, so we can conclude that this is not in the root locus. This line is not in the root locus. Okay, again see, so this is a S is equals to 2 point. Okay, this is S is equals to 2 point, and here you can see that there is only one pole. So one pole means it is odd. If there is odd number of poles and zeros, then you can conclude that this point is lying on the root locus. Okay, this point is lying on the root locus. So see, this is the graph of the S-plane, and this will be the poles. This is 1 0, this is one pole, this is 1 0, and this will be parabol. Suppose this will be in 0, this is in -2, this will be -4, this will be -6, and this will be -8. So we have to check from this side. We have to check for each and every one, and we have to look towards the right side. So see, this is the first pole. So there is no other pole in the right side. So 0 pole, 0 number is 0, and 0 is an even number. So you can conclude that this path will not lie. This path will not lie in the root locus. This portion will not lie in the root locus. So okay, Next comes to this 0, minus 2, this point, this 0. So you can tell that on the right side there will be one pole, okay, and so it is the odd number. So you can conclude that this path will lie on the root locus. Always remember that, or you have to check from this side. If it is odd, then that portion will lie on the root locus, and if it is even, then that portion will not lie in the root locus. Similarly, see from this side, there will be one pole, one 0 and one pole. So the number is 2. This is a even number. So so this path will not lie. This path will not lie in the root locus. Again, check this this 0. So you can see that on the right side there is 3. Total number is 3. 2 poles and 1 0. So you can conclude that this path will lie on root locus. This path will lie on the root locus. Okay. Again, similarly, when you are checking this point, you can see that there are 4. Number is 4. 2 poles and 2 zeros. So you can conclude that this path 1 2 3. Okay, you can conclude that this path from here to infinity it will be there, but here to here there is no path exists, because number is 4, which is even number. Okay, so see, this is, so the point is a point on real axis. So see, a point on real axis is said to be on the root locus if to the right hand side of the sum of the open loop poles and 0, means combination of open loop poles. As I see you see, this is the graph. So here it is, there will be 2 in this portion, there will be 2, so no. And here in this you can check that there is 3, 1 2 3. So you can conclude that from this pole to this 0 there will exist root locus. Okay, so see, this is one example I am taking. GS is equals to K, S plus 2, S plus 6, S plus 4, S plus 8. Okay, so this is an open loop transfer function. This is one open loop transfer function, as you guys can see. And this is a open loop 0, and this is a open loop poles. Okay, so S is equals to 0. So what are the open loop poles? S is equals to 0, minus 4, minus 8. Okay, and what are the open loop zeros? S is equals to minus 2 and S is equals to minus 6. So let's plot the graph here. See, this is the graph. So these 3 are the poles at 0, minus 4 and minus 8, and minus 2 and minus 6 are zeros. Okay, so see, similarly I just told you that if you check from this side, you have to check from the right side. Okay, so if you consider this point, so you can see that there is no open loop poles as 0. The number is 0 and it is an even, so there will be no root locus will exist here. Similarly here only 1, so you can conclude that this point to this point there will lie an root locus. Similarly from there the number is 2, no root locus. Number is 3, so root locus will exist. Similarly here number is 4, so no root locus, and from here it will exist till infinity. Okay, so next comes to the point angle of asymptotes. So what is angle? You have to first of all know what is angle of asymptotes. See, some branches will terminate at infinity. Okay, some branches will terminate at infinity. The p minus of z terminate at infinity along certain straight lines known as asymptotes of the root locus. Okay, as guys I told you that p minus of z is number of asymptotes, as it is called number of asymptotes. Okay, so how to find the angle of asymptotes? So see, this is a formula of finding the angle of asymptotes. So see, theta is equals to 2q plus 1 into 180 degree minus of p minus of z. So this is called the number of asymptotes, as I told you, asymptotes. And q is equals to 0, 1, 2, extend till it will extend up to p minus of z minus of 1. Okay, so suppose this is the example. GS is equals to k s plus 2 s square s plus 4 s plus 3. Okay, so we are first, what we are doing, we are finding the open loop poles and zeros. So here it will be 0, minus 4, minus 3, but number of pole is 4. Why it is 4? Because there are 2 poles at origin, s square. Okay, so it will be 4. It is type 2. So total number of open loop poles is 4. Similarly, there is one open loop 0. S is equals to minus 2. At minus 2 there is one open loop 0. So number of open loop 0 is 1. So p minus of z. P minus of z means total number of open loop poles minus of total number of open loop zeros, means there are 4 open loop poles. As you guys can see, there are 4 open loop poles and there is one open loop 0. So you can conclude that p minus of z 4 is equals 3. So number of asymptotes is 3. So you have to remember one thing, that number of asymptotes is equals to number of asymptote angle. Okay, so if the number of asymptotes is 1, then the number of asymptote angle is only 1. If the number of asymptote is 2, so here it will be 3. So there will be 3 asymptotes angles. 3. What is the formula? Theta is equals to 2q plus 1 divided by p minus of z. So first of all, and q starts from 0 to ... p minus of z minus of 1. So what we can do? First we will put 0 in here. We will start from 0. So see, we put 0 here. So 2 into 0 plus 1, and p minus of z is 3 into 180 degree. Sorry, into 180 degree is there in the formula. So what will it come? 60 degree. First asymptote angle is 60 degree. Then put in place of q, put 1. So see what you will get, 180 degree. And similarly, there are 3 asymptotes. Number of asymptote is 3. So there will be 3 angles. The last one is theta 3. So we have to put 2. So see, 300 will come here. Okay. Okay. So next comes to the centroid. This is the 5th point of solving the root locus. See, what is centroid? You have to know it is the intersection point of the asymptotes on the real axis. Okay, it is asymptotes on the, it may or may not be a root locus. Okay, so centroid is a value. Okay, so you have to calculate for centroid. So means you have to draw the asymptotes. You have to draw the asymptotes from the centroid. So this is the sentence meaning is that it is the intersection point of the asymptotes on the real axis. It may or may not be a part of the root locus. So centroid may lie on the root locus or not. It will not depend whether means it will lie also here. It can lie on this root locus portion, or it may not be lie on the root locus portion. It doesn't matter. So see, what is the formula of finding the centroid? See, summation of the real part of poles minus of summation of the real part of zeros, okay, divided by p minus of z. So as you guys can know, p minus of z is the asymptotes number of, and real part of poles and real part of zeros. So I am showing you one example. See, let's take this example. 1 plus k s plus 4 divided by s cube 5s square plus 6s. Okay, from here first what we have to do, you have to find the gs, because this is in the form of 1 plus gs hs, okay, is equals to 0. Characteristic equation, it is in the form of the characteristic equation. So you have to find gs from here. So, and as hs is 1 because unity feedback, so gs is equals to k s plus 4 divided by s square plus 5s plus 6. Okay. So see, this is s square 5s plus 6 is equals to 0. So what will it become? S square plus 3s plus 2s plus 6 is equals to 0. So s plus 2, s plus 3 is equals to 0. Okay, so gs is equals to k s plus 4 s into s plus 2 s plus 3. Okay, so this is the open loop 0 and this is the open loop poles. Okay, so you have to calculate centroid. Okay, so I am only calculating the centroid. I am showing you how to calculate only centroid. Okay, so centroid means sum of the real part of the open loop poles, minus of real part of zeros, minus divided by p minus of z. So what is p minus of z? See, it here, from here if you calculate, so there are 3 poles and 1 0. So 3 minus of 1 becomes 2. 3 minus of 1 becomes 2. So centroid is a real part of the poles and real part of 0. So it will become p minus of z divided by p minus of z. So minus of, take the real part of poles. So minus 3, minus 3, minus 2 and 0. Minus 3, minus 2 and 0 divided minus of 4 divided by p minus of z is 2. This is a portion of the open loop 0. Okay, so it will become minus of half comma 0. So in this way you have to calculate the centroid. Next comes to the breakaway point. So see, next comes to the breakaway point. So see, these are the points where the multiple roots of the characteristic equation occur. Okay, these are the points. Okay, so see, there is 2 poles. Suppose this is one example, there are 2 poles. This is 1 pole and this is 1 pole. So if you check from this side, there is only 1 pole, odd number, root locus will exist from here to here. Okay, and from here to here it will tend to here and this will be tend to here. So if this is like this, so this is like this, and there will be one breakaway point. Okay, so there will be one breakaway point, so we have to calculate this breakaway point. Okay, so where it breaks away the root locus. So see, Procedure. Next comes to the procedure to find the breakaway point. See, first construct 1 plus GSHS is equals to 0. Construct 1 plus GSHS is equals to 0. Next, the second point is write K in terms of S. Third point, find dk by ds is equals to 0. Fourth, roots of the dk by ds will give the BA point. These are the points how to construct. So I am showing you the example. And to the last fifth point is to test valid breakaway point. Substitute in step 2. Okay, if k is equals to positive, then there will be a valid breakaway point. And if it is